Hello students, welcome to chemistry classes. Today under this basic concepts of organic compounds, we are going to discuss one important topic called nucleophiles and electrophiles. So these topics are very important in the examination point of view as well as the entrance examinations. Nucleophiles are otherwise known as nucleophilic reagents. Nucleophilic reagents. What are nucleophiles? The nucleophiles are the reagents or the neutral compounds or ionic compounds. It must have at least one lone pair of electrons in their valence cell, either neutral molecules or the charged molecules. It must have at least one lone pair of electrons in their valence cell. Electron sufficient centers. These electron sufficient centers are said to be nucleophiles or nucleophilic reagents. For example, sodium hydroxide as a reagent. We know that it is split into Na plus and OH minus. Na plus and OH minus. This OH minus ion, this oxygen atom, OH minus ion consists of this oxygen and hydrogen. This oxygen having lone pair of electrons. This lone pair of electrons are readily donate other electron deficient centers. Therefore, this OH minus ion act as a nucleophile. This reagent is commonly said to be nucleophilic reagents. Majority of the other nucleophilic reagents are also there. Each and every nucleophile must having a lone pair of electrons. The lone pair of electrons, with the help of lone pair of electrons only, they act as a nucleophilic reagents. It attack this nucleophilic reagent attack the electron deficient centers. For example, RCl is or simply say ethyl chloride, RCl, ethyl chloride. It reacts with nucleophilic reagent, that is sodium hydroxide. From the sodium hydroxide, the OH minus act as a nucleophile. It attack the electron deficient centers. So this bond move towards the chlorine. It becomes positive charge, it becomes negative charge. This OH minus ion attack this CH2, electron deficient centers. The Cl minus ion attack this Na plus because Na plus and OH minus. So this is the substitution reaction. Majority of the substitution reactions can be carried out with the help of nucleophiles. Therefore, they are said to be nucleophilic substitution reagents. Finally, it gives CH3, CH2OH and NaCl as the reaction. And the nucleophilic reagents must having a lone pair of electron. In actual practice, it is said to be Lewis bases. According to Lewis concepts of acid and bases, this base is a substance which must donate the electrons. Electron donors are called Lewis bases. Example for Lewis bases: this OH minus ion, Cl minus ion, Br minus ion, I minus ion, Cn minus ion, acetate ion, H minus ion, etc. So these electron donors are called Lewis bases. OH minus ion, Cl minus ion, Br minus ion, I minus ion, cyano minus, hydroxy, chloro, bromo, iodo, cyano, acetato, hydrido, etc. all are having negatively charged species. Negatively charged species means it must having extra electron in their valence cell. In some cases, water, ammonia, etc. These are also act as a Lewis bases or the nucleophiles, which does not having any charge on any atom of the concerned molecule, does not having any charges. So, it acts as a neutral nucleophiles. Why it is called as neutral nucleophiles? These molecules, either water or ammonia, which does not carrying any charges, but this in water the oxygen atom consists of 2 lone pair of electrons. This nitrogen atom consists of 1 lone pair of electron, and these compounds ready to donate the electronic pair to the electron deficient molecules. These are said to be neutral nucleophiles. So, simply say what are the important points about these nucleophiles. Nucleophiles are electron sufficient centers. Nucleophiles are act as Lewis bases. It donate the electrons, electron donors. Donate the electron to electron deficient centers, or simply say it attack electron deficient centers. It must having electron, lone pair of electron in their valence cell. It may be divided into charged nucleophiles or the neutral nucleophiles. The second topic is electrophile. Electrophiles are otherwise known as electrophilic reagents. Electron deficient centers are called electrophiles. The electrophiles are otherwise known as Lewis acids. Electrophiles are otherwise known as Lewis acids. These Lewis acids are otherwise known as electron acceptors. Electron acceptors are called Lewis acids. Example: Zn2 plus, Cu2 plus, and Fe2 plus, etc. All cationic charges. Metal atoms are electron deficient in nature. Metal ions. Metal atoms are, in some cases, metal ions are electron deficient in nature. These compounds carrying positively charged species, 2 electron deficient. For example, Al3 plus 3 electron deficient, and Fe3 plus 3 electron deficient, etc. So which the charge which denotes the number of electron deficient in their compounds or in their ionic state. And neutral electrophiles. Some electrophiles does not carrying the positive charge, but the atom present in the concerned molecule is neutral in nature. For example, AlCl3, aluminum trichloride, and perichloride, ferrous chloride, perichloride, etc. So, these are molecules which does not carrying any charges, electron is not having any positive charges, but aluminum is electron deficient, iron is electron deficient. Here also this is ferrous iron, this is peric is electron deficient. Some compounds which does not carrying any positive charge but behave as electrophiles, they are said to be neutral electrophiles. How this reaction takes place? Let us consider this is an aromatic organic compound. Phenol is an aromatic organic compound. It reacts with concentrated sulfuric acid. Concentrated sulfuric acid is a powerful dehydrating agent. It liberates water itself, SO3. SO3 is a neutral electrophile. It's very important. SO3 is a neutral electrophile which does not carrying any charges. It attack this ortho position as well as in the para position to form an isomeric products OH SO3H plus OH SO3H ortho and para hydroxy benzene sulfonic acid, ortho and para hydroxy benzene sulfonic acid, ortho and para hydroxy benzene sulfonic acid. Here SO3 acts as a neutral electrophile. And another one example, the same phenol reacts with bromine water, bromine in the presence of carbon tetrachloride or carbon disulfide, bromine in the presence of carbon tetrachloride or carbon disulfide. How this reaction takes place? Here hydrogen, here this bond shift here like this, it carries negative charge, and this bond shift like this, here positive and here negative. This positive this bromonium ion, and this hydrogen and Br minus gives HBr. So it gives OHBr, orthobromophenol, bromonium ion act as electrophile, bromonium ion act as electrophile. So electrophilic reagents, substitution can be carried out with the help of electrophile. Therefore, it is said to be electrophilic substitution reaction. So, you must know the electrophiles or electrophilic reagent, charged electrophiles or neutral electrophiles, anhydrous aluminum trichloride, ferrous chloride, neutral ferric chloride, and sulfuric acid. From sulfuric acid, it provides sulfur trioxide, act as a neutral electrophiles. So, in the examination point of view, a group of reagents are given. You can identify whether it is neutral nucleophile or charged nucleophile, neutral electrophile or charged electrophile, and what are the major differences between electrophile and the nucleophile. So, electrophiles, one important point about the electrophile must having vacant orbital to receiving electron from the donor atom, because the electrophiles are electron deficient centers. It must having vacant orbital which act as a store gauge to receive the electron from the donor atom. This is a specific point about this electrophile. Nucleophile must having lone pair of electron. These electrons are donated to electrophiles. The electrophiles must having vacant orbital in their valence shell to restore the electron from the nucleophile. Now, the major differences between electrophiles and nucleophiles. So, nucleophiles are otherwise known as nucleophilic reagents. Electrophiles are otherwise known as electrophilic reagents. Nucleophiles are electron donors. Electrophiles are electron acceptors. Nucleophiles are otherwise known as Lewis bases. Electrophiles are Lewis acids. This consists of two categories, charged nucleophiles and neutral nucleophiles. Electrophiles also having two categories, charged electrophiles and neutral electrophiles. Nucleophiles donate the electron. This is gain of electron takes place. So, I hope all these concepts are clearly understood about each and every people's. This organic chemistry is the basic part is very important. If you learn thoroughly in this topic, you can get more ideas and you yourself write the equation in a own way with the help of these conditions. Thank you.